next presenter is Dan Keithline with Keithline Engineering, and he will be giving us a presentation, project briefing, restoration of Waurika Lake to a resilient regional water supply. And he will have twice the amount of time as Mr. Crooker. So 20 minutes, please go ahead and start.
Thank you, Anna. Appreciate you all coming out. This is kind of an exciting topic these days, especially when you see the new stuff here is virtually over. And so now everything we're going to be doing pretty much from this point on will be repurposing, rehabbing, replacing in kind, things of that nature. This project was very interesting from the point of they had a lot of issues. Here's our project briefing phases right there, all listed up there. And essentially, this is a lake that has about 10,000 square acres of surface area, and it's 187,000 acre-feet of storage capacity and its prime focus or its prime purpose is for water supply. And so essentially, it went through a drought period where it got down pretty low. And we'll get into the details of that and what they did and how we approached it. Essentially, phases 1 through 8 go from there. The location of the project is in southwest Oklahoma. It's half the lake is in Jefferson County, and the northern half is in Stevens County. Essentially, the lake is 27 miles upstream of Beaver Creek from Red River, so it's real close to Texas. As I mentioned before, it's about a 10,000 acre lake surface area. The construction was completed in 1977, so it's approximately 39 years old as of today. Storage capacity 187,000 acre feet, and then the purposes down there are listed at number 6. Flood control, irrigation, the typical stuff that pretty much any lake would be listed for of any kind of significance. The WLMCD, which is the Waurika Lake Master Conservancy District, that got its authorization from the state of Oklahoma in 1961, I believe, it conveys anywhere from 10 to 34 billion gallons per day to its member cities. So that's where, and I'll get into that right here. Here's the member cities. It goes, the conveyance system goes as far north as Lott, and then Walters, Temple, Waurika to the south, Comanche to the east, and then Duncan to the north. That's the 5 member cities. It serves 275,000 people for drinking water, which is approximately 8% of the state's population. It also serves Fort Sill as a major water customer, and it expands out over 4 counties. The one thing that this situation here, it had an intake, and the bottom gates didn't work. Not only did it work due to other issues, but also they couldn't access the lower bottom of the conservation pool. So essentially, one of the main objectives here was the dredging part. So that was real critical for this. And so this was one of the first dredging projects in the nation that received a 408 permit since it was introduced in 2005. Here's the assessment of the conditions that are out there. Under normal conditions, there's essentially 46 feet of normal water depth with a normal pool elevation of 951, which is 187,000 acre feet. When the drought came on, the drought took it down 19.5 feet down, essentially reducing it down to less than 30% of its capacity, storage capacity. And so, and then with the siltation, or with the sediment deposit problem in the channel that feeds this structure, that's the intake structure, the access to the, it really minimized the access to the lower conservation pool. So the only accessibility it had was the middle 8.46 feet, which is 25,000 acre feet. So it had a couple different problems. One problem was the evaporation and the lake losing water elevation due to drought. Secondly, it couldn't use its bottom gates to access the lower parts of the conservation pool. The state of Nevada just got done with their big dam project where they had to get access to the bottom part of the conservation pool. So this is a critical, this is a normal problem throughout the United States. Most facilities that I know, the bottom gauge don't work. It has sediment problems. And obviously, as your lake goes down, it develops water quality problems. And the lake got so bad that actually it was considered a level 4 drought, which is the severest of all. Then, we put again all the plans and specifications and applied for all the permits, got almost all the permits, and then we decided to bid the project, put the bid out, and guess what it started doing? It started to rain. About 20 inches of rain that brought it back up to almost over 270,000 acre-feet. So that was kind of unusual. So I guess one person can take through this is that if you want something to happen, you definitely put it out there to counteract it. And in this case, we put it out to bid and it started to rain. Fortunately, the depth there still allowed us to proceed with the project, mostly because of the client and his board understood that this was an issue that had to be dealt with. A lot of times we kick the can down the road and people don't want to address the problems at hand. They still wanted to handle the issue here. And the issue was access to the lower conservation pool during drought. So the project goals was obviously to increase dependable yield due to that. Also and get access to the elevation of the conservation pool. Also, another thing too was they didn't want to, if we did the dredging project, they didn't want to come back 10, 15, 20 years and re-dredge it. Those bottom intake gates were constantly being silted in. And essentially it had 18 foot of silt against it, of sediment deposits. And so we felt, we believed that we wouldn't be back here 15 years later to re-dredge it. And so they didn't want to go through this thing again. So anyway, they decided to, we decided to study the issue and find out what options we had on our plate. And one of the options that rose to the top, mostly due to money, because it was the cheapest option, which makes it pretty easy now. And the, essentially the, let's see. We looked at different alternates, and essentially we decided to, this intake, that is right here, you can see a channel. It's underneath the water, was silted in, and so if we would dredge that sediment out, remove it, and then put a pipe down the center and have a floating intake at the end, in the future, when the sediment would redeposit, it wouldn't be an issue because we'd have a pipeline and a conveyance line. And so that conveyance line can do up to 30 million gallons a day. That meets the mission of the original station, an intake facility, a pump station. And so anyway, here we are. We're off and running. We got all our ducks in a row as far as meeting the goals of the original deal, and we go from there. We also looked at some of the alternates. We looked at some of the things of boring underneath the lake. We looked at certain type of barriers to minimize sediment deposit into the channel. And anyway, this one rose to be the best one. Essentially, one of the big things, there was a lot of players involved here with the Corps, with the WLMCD, Dave Taylor there as a board manager, also the board, and also all the sister cities, the Corps of Engineers, Bureau of Rec, just a lot of people involved here. And so one of the things that was real good about it, we had bi-weekly meetings that really pushed the project. And we didn't have them all the time just to have them. We had them definitely in critical phases of the project to make sure it kept pushing along. Here's some of the phasing that would be advertised. I won't go in and read it all, but essentially some of the completion dates are down there at the bottom. And like I said, we bid the project in April of 2015, and it started to rain in June of 2015. Fortunately, it rained right before the mandatory pre-bid. So the contractors came out, looked at the job, they saw the lake full. The contractors didn't get, they said we can still do it. And so anyway, with them still saying they can still do it, we decided to proceed on with the project. And it had very little cost impact to the project. Here's phase Phase 3 was the permitting part, how the project is broken up into different tasks. One of them is the maintenance and monitoring and management, going along with the task 2, which is the dredging part. Task 3 was the lower gate extension, which we installed new gates, but we also extended out the gates out to the center of the lake with a 30 MGD floating intake. Proceeding on, Phase 4, we did the design of the CDMSAs, the confined dredge material storage area. And anyway, this is utilized to hold the dredge slurry to allow it to decant and clean up before we release it back to the lake. Here's the, there's the original green line. To the left is the supply line, and the green line to the right is the outlet back to the lake. Of course, we're going into Phase 5 with all the plans and pulling them all together. Everything is designed and approved at this point, including the environmental, with the exception of some particular stuff. We actually did have all our permits in place when we bid the project, but we utilized a real creative proposal that would allow us to adjust to anything that the permitting people would throw at us. So we bid the project as a base bid with alternates that could adjust to any situation that they would throw at us. And so with that, real easily allowed the project to proceed 2 months ahead of time. Proceeding on here, we on the permitting part, these are all our lists of our permits, including the 33 USC Section 48, which was kind of unique for an inland project. We also got our FONSI nationwide permits 12 and 16. Real estate right-of-way and entrance documents as far as to accommodate not only the project activity, but also the future activity for maintenance. That's one of the big things we try to definitely plan out, not only the maintenance, but also in the future when they replace it. So we talk about that life cycle cost analysis. It should also include maintenance as well as replacement in the future to have the true dollars of what a repair would cost. Of course, ODEQ down at the bottom there, we did get a discharge permit from there. But one of the things there, we did best practicing materials on the stormwater applicant. On the phasing and funding part, Phase 6, this was huge. OWRB loans, as well as the Bureau of Rec came in with a grant. FEMA, as soon as it rained, FEMA was going to supply some funding for the project, but because it rained, it was no longer a drought project, and we lost that money. We think it could have been $3 or $4 million. Here's some of the tables that we monitored, the CDMSAs on its discharge concerning the intake water on the environmental part. Here we listed everything from the TSS to pH as well as water temperatures and NTUs. Here's some of the instruments we used in the field to monitor that and to take those measurements. Here's some of the geotechnical measurements that we did at the bottom of the CDMSAs in order to document what the existing background conditions were. Like, in other words, the existing background soils could have obvious background stuff that would not be desirable to have. So anyway, we needed to know that baseline. So that way, when we put the sediment in there, it would show up as being an additive. One of the big things we encouraged and also had requirements in our specifications about safety and including any kind of oil spills, which is real a possibility when you're dealing with construction equipment right on the edge of the lake, which we all know. The name of the project here, we called it the Dredge Gate Extension and Gate Replacements. So that was kind of an interesting title, I thought, that we came up with. We talked about this for, I think, for 4 hours in the group right here. This is Bob, Joe, and Jim. The facility here is more, like we talked before, it's more in the center of the lake. That's one of the problems of this situation. Is a little different than normal. The intake is located not at the bottom of the lowest part of the lake. The actual outlet. I'm not sure if this has a. Anyway, the actual outlet for the lake is down here. And so, due to the wisdom back a long time ago, they decided to move the intake right here, which is about halfway down the gradient line of the original creek that went through here, Beaver Creek. And anyway, so the combination of that location, in the summertime when they're pumping heavy, they're pumping 30 to 35 million gallons out of this, that any sediment that gets in here is attracted to this channel. Here's the channel that's underneath the water. So essentially you have all the sediment that's in the lake is going up here, up to this field. So this channel, the sediment deposited was thicker than normal because the rest of the lake is doing pretty well. But this channel had up to 18 foot of sediment against the intake. Here's some of the contours and some of the exhibits that we use to demonstrate the locations in the contouring. Other exhibits here showing showing some of our activity. Here's one of the easements. Well, this was kind of interesting. We again here we not only got easements for the construction activity, but also for future maintenance. So we didn't kick the can down the road. We addressed it, and so that way, when someday when they have to do maintenance on this or replace it, they'll have the easements in place to do this work, and they won't have to go back and do anything else. Here's some of the bid items. I think it broke down to be about 45 bid items. Again, there was 4 tasks, major groups of activity, and here's a listing of some of them. I won't go read them all to you, but anyway, that was remove and replace. We removed and replaced 6 4x6 slide gates, which would come about. Essentially, some of the monitoring we used was some survey, from bathymetric survey. Here's some kind of slides that show this. I know I'm out of time, but real good. Yeah. We also monitored it with some Lowrance equipment. And the boat there. Here's we're sinking in some of the 4,000 foot long, 42-inch HDPE pipe. You can see the concrete anchors around it. They were 25 foot on center. Again, here's another photograph showing some activity of sinking the pipe. Here's some some tricks that we did to monitor the contractor's positioning, and so we had an understanding of this is the 2 lower intake gates that the pipe came in and it came up to 2 and then went into each chamber. The intake has 2 chambers, an east chamber and a west chamber. So essentially they could do maintenance on one side while the other side is operational. Here the pipe's coming out. This is about 1,000 foot long right there. And so this is, you can see the little right there, that's that, the blow up of that. This was kind of neat, and this helped the WLMCD board understand what was going on, because a lot of people didn't really understand what was up. And so things like this really showed people what we were doing, how we were doing it, how we were monitoring the construction quality, real critical. Again, they're not always, it's my experience with construction, as long as a contractor knows you can check them, they usually do a better job. And so you make sure that they know that you can check them. And so even with this type of stuff, we made sure the contractor knew that we could check them, and he did a reasonably good job with the exception of a few minor things. Of course, they're contractors. So this is the intake right here. This is the original Beaver Creek. So we have a floating intake there right on top of it. So and then here's an anchor, a cable and an anchor to it. So that kind of shows you some of the action. Here's the intake. This intake is awesome. It's 114 feet from the bottom of the footing to the top. It is just huge. Anyway, you see it's broken up into 2 chambers, east and west. And here's your lower, middle, and high intake gates. Each gate is 4x6. And anyway, it was so the intake facility is just an awesome. And they did a real good job of planning out a lot of replacement in that facility. I was really excited about that. Here's the gates that we replaced. Had major tuberculation. Because of all the tuberculation, and it really restricted its movement. And anyway, we decided to put stainless steel gates in, and that seems to be working pretty well, with the exception some leaks that we're in the middle of correcting. But that was a big deal, ductile iron versus stainless. Here's some of the issues they're still trying to get these gates. And so repaired is still shooting out some, it has a few little leaks that doesn't meet the specification. But they're going to repair this here, I think, next week. There's some more shots, some concrete repairs we did inside. There's that's a shot from down below at the high intake right there, gate. Here's task 2, which was more of the CDMSA facilities in the building and construction part. Here's the original profile that shows the sediment. As you can see, here's your intake over here to your right. You have your lower gates, mid gate, and high gates. And you can see here's the 18-foot of silt. The original channel is down here. So you can see that 4,000-foot channel had attracted quite the sediment deposits that's inside. Here's another shot. Here we put a plan and profile together, and we actually depicted these areas separately. We thought the contractor, the dredging contractor, might bid these separately, and the pricing was real close. But again, there we wanted to give the contractor options to. We always want to make the contract specifications as fair as possible, so that way the contractor feels comfortable, and that way he gives you his best price. Here's another part of the facility for erosion control, showing the CDMSAs, and then here's your intake over here, and then here's your CDMSAs to the right. Fortunately, we had a lot of land, so we could spread out a little bit. The CDMSAs are 18 acres in surface. Here's some erosion control stuff. There's some more exhibits showing the CDMSAs as they're being built. Again, there it's 16 acres to the top, and then the one on the bottom there is about 2 acres. This is showing, here's what the slurry looked like when it was coming out of the end of the hose. And we made sure the contractor spreaded it out or kept relocating the nozzle so that way it evenly distributed in the CDMSA. So we were real pleased about that. Here's another shot where we're constructing these CDMSAs, which is confined dredge material storage areas. And that started last August. Here's some better shots, some aerial views, some drone video we even have. That was one thing that was a real success, was the drone videos. Again, they showed to the board when they approved the pay request of the contractor for like $1.7 million. If they see this drone video, they kind of get a gist of what they're paying for. It really helps understand. There's the different, we used, Dredge America was the successful bidder. And that's a cutter head technology with suction that was required by the contract specifications. Here's your intake boxes that is decanting the clean water off the top. There's your turbidity curtains and your outlet discharge, 2 12-inch pipes discharge. And I think they could have just did with 12-inch, but they decided to put 2 there. Here's an aerial shot or drone that was out there that circled the activity. And here's the dredge equipment. Here's the intake. Here's the storage pipe, which will be the 4,000-foot of pipe that'll go along the underwater channel. And then here's the dredge slurry is going to that pipe up to the CDMSAs, which is over to the east and north of the lake.
There be I hate to interrupt. But
yeah, we'll put on the side top.
Almost. We are already over time. So if we can watch the drone video.
Do you want to do that?
Well, it just depends. How long is that? So I just want to honor everyone's time.
Let me just kind of go through. Let me just. I think if we show a drone video, I want to throw the one that's better.
Sure. We want to do one.
Okay. Here's some more activities. How we put the pipe in the water. Divers. We had a great diver. Knew the laws of buoyancy. We also we monitored the quality of the HDME pipe, and we had to redo 20 joints. Again, there we told the contractor we could check them. We told them how we were going to check them, and then when we did check them, then there was 20 joints that didn't make it. so they had to redo it. So here's some more layouts. Floating intake, 30 MPD, photographs, buoy, cage with a 30 MPD. There it is right there. Anchors, expansion anchors as well as concrete anchors for weight. Last activity, project cleanup. The CDMSAs will now are going through a three-period activity, and right now it's in period 2, where we're essentially isolating and decanting the free water, and we're almost done with that process. The dry out has started, and also our sediment is settling. So, and then from there we'll do an original reclaim the land back to its original condition. I think this is the one we want to do. Can you hit that?
Thank you so much. That was very informative, and I'm sure the group will have a ton of questions after we get to that